All right.
All right. Well, yeah, so I'm here to talk about functional composition in Ruby. And like I said, for many Rubyists and stuff, it's just not talked about much. And I think it's kind of a shame because I really like using it in Ruby. But again, I'm really curious to see what you guys think as we go through this, especially since you guys have much deeper knowledge with Haskell. So it'd be interesting to see how this overlays in Ruby here. So from an overview perspective, what I'm going to kind of walk through in this talk is talk about the fundamentals of Ruby, what we have in Ruby already that gives you functional composition and functional programming, I should say. And then I'm going to add on a gem. It's called dry monads that actually gives us monads within the language. It's a gem that you install. And then I'm also going to talk about the pipeable gem, the gem that I maintain is open source, which basically puts all this together and allows you to have a fault-tolerant pipeline when you put monads together in various steps. So what is functional programming? I think for you guys, I'm just pulling from Wikipedia here, right? Being able to take various functions, right, and compose them together, right, in order to produce a result at the end. For this crowd, I think everybody kind of knows this, but just providing that there for context. So what does this look like in Ruby? Well, here's a good example where I'm using a lambda here basically to define a number, and then I'm going to add it by 3. And that's really it. There's not much to it, really. And then I'm going to have a multiplier here that's going to take a number and just multiply it by 3. And in Ruby, where this opens up is the forward composition. That's the 2 greater thans there. That allows me to compose the adder and the multiplier so that I can take the value of 5 in this case, run it through the adder. So I'm going to add 3 to it, and then I'm going to take that result and multiply it by 3. And that gives us a result of 24. And there's the math for it. So that's what it looks like in Ruby to actually do function composition. Does that syntactically track okay? Is everybody kind of comfortable with that? So a little bit of history here. So function composition wasn't always in the language. It actually came about in Ruby 2.6, and that's where they added the forward composition and backwards composition methods. And those were added to the proc and the method objects in Ruby. And I'll explain more of that here as we go into the fundamentals. And I want to break this down by the various types of objects within Ruby that can have this so that you can kind of compose these in different ways, in interesting ways. So we've got procs and lambdas and methods. Classes are a little bit of an oddity. They don't have it by default, but I'll show you how that is made possible. So again, if we go back and we look at procs, and we use proc syntax here, and we have and we look at it, right, we can see that it's a proc. If we inspect it, we see that we have an instance of a proc. And then if we call 3 times 3, it's going to get 9. And if we change the parameter here, instead of the default of 3, we change it to 10, we're going to get 3 times 10, and that gives us 30. So just simple math, but this is important because as I walk through these, you can kind of see the differences in syntax. So next up is lambdas. Now, lambdas are basically a proc, but they have additional special abilities, which is they care about parameters, and they have some other things like in terms of what they return. But the main thing for this talk is that they care about the parameters. Procs do not. You can just not give them anything and they'll be happy. Lambdas, if you don't give them the supplied parameters, they will be upset and throw an argument error. I think that's right. I think it's an argument error. So in this case, the syntax only changes slightly. Lambdas have the stabby syntax to make it a lambda instead of a proc. If we look at it, we see that it's still a proc, but if we inspect it, the key thing here is that it's a different type of proc. It's a lambda. That's what makes them different. Then if we call it, again, multiplication here, 3 times 3 is 9, and 3 times 10 is 30. Nothing different there implementation-wise. So if we move on and we look at methods now, what I'm doing here is I'm taking a module. I'm just making an anonymous module, and then I'm assigning it to a constant here, calculate. And then inside there, I'm just defining this method definition, but I'm creating a class method here called multiply. And you'll notice that it's multiplied by 3, same defaults that I had for the procs and lambdas. But what I need to do, though, is I need to pluck that method out of the module so that I can have a instance of a method object. And so if I look at multiplier in this case, we'll see that it's an instance of a method. If I inspect it, we'll see that it's part of the calculate module that I was creating up above. And if I call it, again, multiplying, the math works out the same. Now, one key thing here that's important to note is that it's a method object, but if we wanted to turn it into a proc, we can actually cast it by using toProc. And if we look at it, we'll see that it's a proc, but it's a special kind of proc. Once again, it's a lambda because when we plucked it out from the method object, again, a method cares about its parameters, and so does a lambda. So we can't just get a proc back that would actually lead to errors down the line. We need to have a type of proc, which is a lambda in this case. So then moving on to classes, we've got a little bit of additional code to write in order to make it functional, which is we're going to set up a constructor here and have our default by come in as a default parameter with a default value, and then call. So I didn't point this out in the other slides there as I was talking about procs, lambdas, and methods, but basically the entry point into functionality within Ruby is having objects that adhere to the call API. Basically a method that any object that I can send call to means that I can do functional type things with it, because when I have a class like this that has a call API, that means I can swap it out with a proc or a lambda that quacks that way too, because this is duck typing and object oriented. So as long as it quacks like a function, then that means I can swap it out with different types, like a method, a proc, or a lambda. That's what unlocks the power.
Question.
Yeah.
So you want the call to just one input parameter, right?
In this case, yes, because I'm just having a number that I want to multiply it by.
No, but in general, you could have a arbitrary number parameter.
Oh, yes.
Yes. Or you want to have just one always, so it's sort of the call API and quarks the same way.
Yeah, in this case, because I wanted to behave the way I was showing you the implementations for procs and lambdas and methods, just one parameter coming in. But in Ruby, parameters are actually quite rich because I can have positional parameters, I can have keyword parameters, I can have splatted RESTful positional parameters, and I can splat out my keyword args. And then finally, at the very end, I can have a block that comes in. Mm-hmm. So it's actually quite sophisticated just how well, how much you can manipulate parameters.
It's not as much about the Ruby itself, the question is about what you want to do to sort of have this functional aspect that you maybe become clear once we
you mean like when I actually initialize this?
Because a functional program, because like one of the things you want to have is partial applications, right?
Yes. Right? Yeah. Yeah.
And here you're clearing it by saying the first argument is hard-coded to be initialized.
Yes.
And
in
the
this case.
second one is in the, so you're not partially applying, you're just finding it in the on the circle on the right. You're defining you normally is the caller who defines how things are occurring. How partially applied.
Yeah.
And here you are defining on the implementation side.
Yeah.
It's kind of weird.
Yeah.
Yeah.
Right? Yeah. That makes sense. You can actually have this object. You can take an instance of this class here, new it up, right? And you could actually add basically the toProc that I was showing you guys in the other slide. You can teach this class to actually produce itself as a proc, which then you can actually get into the currying that you're talking about. Because with classes, because this is on the OO side, I can't actually by default make it behave that way, purely functional. This is kind of, I'll get into this more in the next slides. I'm basically teaching my class to behave and quack that way. But if I really wanted to like not only be functional, composably functionally, right, I would actually have to add a little bit more to the object API here, making it have a toProc, a casting method, to turn it into a proc, so I can do the currying that you're talking about too. So I can get kind of, I think, where you're going. I just don't have that with a normal class by default in Ruby.
The question is much for me to understand. Try to understand why do we have one parameter, because maybe I was thinking maybe it's somehow related to this aspect of sort of currying. Okay.
Well, so
yeah, so sorry, yeah.
Yeah, so we could have more parameters. The reason I'm just sticking with one is I just wanted to keep it simple so you can see the differences between the types of objects I'm talking about here. But there's nothing stopping you from adding additional parameters here. And then if I refactored the lambda and the proc and the method I just showed you so that they have all those, you can, like it would still work, is what I'm saying.
Mhm.
And you could partially apply it, right, by currying and adding one parameter, and then later adding the next couple of parameters. And finally, when you flesh out all the parameters in which, you've curried and it gets the last parameter, it actually executes. You could still pull that off here as well, if that makes sense. Yeah.
Another question. You mentioned earlier that the composition operators are methods on proc and lambda, or proc and method?
Proc and method.
Because lambda is a proc.
Yeah.
Okay. But so like this, you couldn't pass this multiplier
Yeah.
to the composition because it's not a proc. You need a two proc.
Yeah, no, good call. No, not yet, but I'll show you how to enhance this so that it will play nice. Yeah. But by default, classes can't do that. Yeah. So like I said, in this case, this opens up the functional aspects of having a normal object being able to quack and behave like a function. So again, if we walk through this here, it's just a little bit different, right? Because instances of a class are not going to completely behave the same way as we have with methods, procs, and lambdas. Because if we look at this, we'll see that, yes, it is a class of multiplier. It is an instance of multiplier. And if we inspect it, we see that we have the instance there. If we call it same thing as before, but where it gets a little interesting, right, is if we want to change what we're multiplying by, I have to new up a different instance. So I'm going to get a different instance with a default of 10, and then I'm going to multiply that by 3. So it's not quite as convenient as the methods, procs, and lambdas, but it gets us close there.
And sorry, just one more thing. So you can't, in a definition, a method definition, have like a default parameter, like a number comma by equals 3, and instead of having an initialize, like, is that an option as well?
Yes, I could totally do that here. The reason I'm not is because I wanted if it makes sense here, let me go back one slide. Oops, I went back too far. Hang on a sec. Where am I at? Let me go back to here. The reason I wanted to keep it with just one parameter is because, I could actually, it's a good call out, because I actually am providing the default here, like what you're getting towards.
Right.
The reason I didn't do that, so here, let me go forward here. Hang on a sec. Let me go back to the class. Yeah, okay. The reason I did that here, and your point is absolutely right. I could have the call method defined with number, and then by is that optional parameter that defaults to 3. You're absolutely right. The reason I didn't do that is because I don't really have a class anymore at that point. Because if I'm not injecting any dependencies into my class, it doesn't make sense to call it a class. So that's why I'm doing it this way. So it's a very good call out.
This class approach though looks more like carrying, right? Where you're like, oh, we can make an instance with this as the, basically now I have this partially applied function.
And then later I'm going to supply the second.
But the implementer defines the carrying, not the caller of the API. Right? It's done on the other end. You're telling me how it's being carried, not that I cannot carry it.
Right, yeah.
Yeah.
Because like we have a partition here where these parameters are like in the first set and these are the second set, basically.
Yeah. And that's a really good call out because, and again, the only reason I'm doing this is because in Ruby, this drives me nuts. People do this in Ruby, but they'll create a class and then they'll have just a method here. But when you do that, you're breaking, you don't really have anything that encapsulates anything. There's no reason to new this up. It shouldn't be a class at that point. It should be probably a proc, a lambda, or a method. So, but anyway, yeah, really good call out. Okay, so here, let me jump ahead here. And then, yeah, the math works out all the same. And then, like I was saying, we just had to new it up differently. So now that we kind of have the fundamentals down, now we can kind of go into composition. I can show you how we can teach the classes to behave in this way too, and how we can compose all these together. So then it'll finally fire and then compute the result. So not as elegant as Haskell, but still very possible in Ruby.
Okay.
The one thing to note though is when you do that, it is just slightly expensive. The reason is because when you query, you're basically creating another instance of a proc at that point. So it's another object in memory. So we don't. It's just the nature of O, right? Like we don't have the benefit of in functional where it's more streamlined, and so there's a little bit of a slight cost when you do that in Ruby. Yeah, yeah. All right, so let me jump back. Okay, so now why is this popping up? Can you guys see that? Oh, you guys can. Okay. Anyway, so the thing here is I just want to get into actually composing this and being able to mix and match these in different orders. So with composition, there's a little bit of assembly here. So like you were hinting at before earlier, right? I need to still show you how to teach classes to behave well. That's the only thing that we have to do. And so in order to pull that off, to answer your question, is you want to have a module then that is composable that defines both the forward and backward composition methods, and then also have call in there so that this can be, if it's not implemented, it needs to throw an error. And so Pipeable actually provides this for you. It basically provides this module so that you can, when you use Pipeable, you can teach all your objects, all your classes in Ruby to be composable so that they'll behave nicely. So if we go ahead and use that, let's say that we're going to create a divider class in this case. We'll go ahead and we'll include composable. That gives it the behavior that we need in order to be composable. It needs to have the call method and it needs to have those two, the backwards and forwards composition arguments. Sorry, I guess I don't think I had anything more to say there. I think I just wanted to make sure that, yeah, so implementation is not any much different than what you saw before. I'm just bringing in composable in this case. So if we keep going down this route, let's go ahead and we have a divider that's a class. Let's make a multiplier again that is from a module. So it's going to be a method. It's going to be a method object. And it's not much different than what you saw before. I'm just using multiple lines to represent it this time. And then here we can actually start to play with these. So there's our proc, that's going to be our adder, our lambda is our subtractor, our class is our divider, and multiplier is our method. And again, the only way to make the class play safely is it needs to be composable in this case. So then with all these together, we can start mixing and matching these. So if we take an adder and a multiplier and we use forward composition, we're going to pass in 10 and then compose it and get 39. And if we do backwards composition, the key thing here is that we got to flip the order. Otherwise, the math won't work out properly. So that's something to be aware of when you're playing with backwards and forwards. Personally, for me, I basically only use forward composition. I think it's a little easier to reason about. I don't really like mixing and matching, but there are some advantages here. In this case, they both equate the same, and there's the math too if you need it. But there is a readability problem. And one of them is in this case, you have to read from the right, then you have to read left to right. So again, I still like it this way, but it's a little annoying. In this case, though, you actually read from right to left the entire way. You don't have to jump. The eye doesn't have to move. And I'll get into this a little bit more here in a bit. But this is what we get with Ruby by default. And like I said, I prefer the left to right versus right to left. The other thing here, too, is if we have all these together, right, there's the math again. We're just basically adding, multiplying, subtracting, and dividing. And then if we flip it, right, same thing. We just have to flip the order in which they're defined. And then here is where you can kind of compose these together. So if you wanted to make an adder and a multiplier and you compose them together, you could assign it to a new value, add and multiply. That would be a new proc in this case that's composed of both of those. Same thing with subtract and divide. And if you wanted to get really crazy, you could have something really big like this that puts all those together. And again, that still works out the same. So if you bring in 10 in this case, same math as you saw on the previous slide, same thing, same result in the end.
And you can do this because those procs, is that right?
In this case, those were all procs, yeah. But if they were lambdas or even a method, it would be fine too. Actually, sorry. No, actually,
Classes would be a little unwieldy, right?
no. Actually, sorry. I was incorrect. I told you the wrong answer. No, that was a mix of all four types. It was a proc, a lambda, a class, and a method.
You're not showing.
Oh, I'm not. Oh, here.
What is that?
Let's see. Did it? Let me. Oh, that's weird that it dropped it. Okay. Is that better? Do you see it on your end?
Yes.
Okay. So yeah. So when I was building all those up and I had the types, I'm mixing all four of those in that case. But remember, the class only works because I added in the composable module. So again, like I was saying, order matters. And then also, this is kind of a bummer too, is that when you're using straight Ruby code like this, in the case in which I have the divider class in there and I've divided by 0, we all know that you can't divide by 0, you're going to get an exception, right? Well, this is fine for native low-level Ruby because you're going to want that to blow up. But the thing is that it's kind of like a series, like a series of Christmas lights. If one light goes out, it's going to destroy the rest. It's going to cut out the rest of them. And you kind of really don't want that because in a good railway pattern pipeline type flow, what you really want is if the divider fails, you just want it to nicely pass out as a failure at the end, not blow up and throw an exception, because you can do something interesting with that. And so by default, Ruby doesn't really give you that. So the question is then, is there a better way? And my argument is that there is with the pipeable gem, because when you take all of what I've been talking about here, you bring in monads and you blend this together, now you can actually start to use the railway pattern. You can actually have fault-tolerant pipelines here. So the way that works is pipeable is built on top of Ruby functional composition, like I've been showing you, and then it brings in monads, and then it ties that all together to build these kind of pipelines. And I'm going to show you what that looks like. So in the railway pattern, again, just kind of a refresher for folks. Some of you probably know this really well. Some of you might still be new, but basically, if you have a railway pattern and you have like the number 10 coming in, we're doing that multiplication. In the success path, you want a success to pop out at the end. But in the failure case, you might actually want to be able to either correct the failure in some way, massage it and turn it into a success so you get the same result in both cases. Or if it's still yet another failure, maybe you can understand what that is too, add it into your pipeline operations, and it still massage that and turn that into a success. And if all else fails, it pops out as a failure, not an exception, but at least you have multiple ways to get a success. And if all else fails, you have a nice failure path that goes down. That's the railway pattern.
Why is it called railway?
So it kind of looks like a train track, actually. So if you kind of pretend that we're on a train track here and it forks, right? You've got one path that is a success. You got another that is a failure, and then but it's another. I'm going to stand up, but it's another track and then another track, right? But you've always got basically a union type. You're either getting a success or failure, if that makes sense. So what's nice about this is, so I'm going to pull from Elm because Elm, by default, because it's an immutable language, has a compiler and compiles down to JavaScript. At the end of the day, it's all built on monad. And again, I don't have the Haskell knowledge. I'm leaning on my Elm knowledge, but it is really nice to be in a language like that where monads and that is built in by default. They're always there. You can't not have them. And in Ruby, by using the pipeline gem, I'm able to actually bring that to the language. So to get into monads then is steal a page from Kierkegaard. If you've ever been into Kierkegaard, it's one of my favorite video tutorials out there. They all have this thing like in a nutshell, right? And so I'll explain monads here just briefly. I won't spend a lot of time on it. But with the monads gem in Ruby, basically what it gives you is it gives you a success or a failure. And in Elm, the equivalent of that is an OK or an error. And the nice thing about that is it can't be both. It can't be none. It has to be one or the other. And that's known as like a union type, or I think what Elm calls it these days is a composite type. I actually don't know what Haskell calls this. Like, do you use union or composite
So
terminology?
you say like a sum type.
A subtype?
Sum.
Oh, a
SUM,
sum type.
yeah,
Okay.
versus like a product type, which is like a tuple, like multiple, like a struct or something.
Okay. Okay. Gotcha. Okay. Cool. So yeah, and so that's monads in a nutshell. What you get by using the dry monads gem in Ruby to give you that success or failure. So let's put all this together then and look at like a quick script that actually pulls this all together so you can see how this actually flows. So what I'm going to do here is I'm using a bundler inline script, and basically it allows me to write a Ruby script in one single file. And it allows me to also bring in my dependencies, so I can just kind of write things as one big script. Now, I'm going to split this across multiple screens. It's not a very large script, but I'm just showing you what I'm doing here, how I'm breaking it down. So I'm bringing in some debugging gems here just to help with debugging purposes. I'm bringing in the HTTP gem because it's a really clean API for doing HTTP calls in Ruby. Dry monads gem, like I was telling you, and then of course my pipeable gem. So then as we go further down in the script, I'm going to create like a little class called pinger. And all we're going to do is we're going to have it basically check to see if a site is up and down. Doesn't sound too terribly exciting, but there's some interesting things going on here. First off, we've got our class. We're bringing in the behavior through the pipeable gem. That gives us the composability that I was telling you about and showing you in the other screen. And then it gives us a bit of a DSL here too. But before we get to that, in our constructor, we're going to inject the HTTP client so we can use it. And then finally, we're going to have that call method. And here's where the pipe syntax comes in. So when you bring in pipeable, it gives you pipe so that you can pass in your URL in this case. And then have additional syntax here of being able to do like T. So like T in bash, right? Like if you pipe multiple commands in bash and you put a T in there, it's just going to pass the first argument, or sorry, the result of the first command in the pipe through T to the next, but then it's going to have like a side effect that doesn't affect anything. So similar here to what pipeable is doing. Then we have a check to see if it's like a secure HTTP request. And then as is just basically a casting step. Basically, it takes the HTTP response, converts it into a status so that we can report on it. So that's the DSL that pipeable is doing. Now that's a limited set that I'm showing you. It actually has quite a few others, basically steps that you can use in your pipe. But these are just a small set here for demonstration.
And are these functions like T and check, do they return a proc? Is that what's happening?
So what they do is they return a monad actually, and I'll show you that in a few more slides. But they're all meant to be composable. So the idea is any one of these could be a proc, a lambda, a method, or a class that is composable, if that makes sense. Okay. Yeah, and I'll lay that out in just a little bit. Interesting to see how you guys feel about it.
Split into two, and then you have two operations next.
So in this case, no, because what it does is it basically handles the side effect of being able to print that you're checking the URL in your console as an output.
That's what puts in it. That's what's
Okay, so
yeah.
So T
swallows
the check.
No, what it does is it's going to have a monad coming in. So basically, it wraps URL as a success monad. T gets that and says, "Hey, I don't care about this thing. I'm just going to print out this message." It's basically puts in Ruby as basically sending a message to IO, standard output, and it's doing that on the kernel object. You just say kernel.puts is basically how you'd write it, and then whatever string that you want to print out to the standard output. And so what T's doing here is it's a side effect saying, "Hey, I'm printing this. I don't care what I got. I'm sending it on to the next step, which is check in this case." If that makes sense.
It's still pretty much a composition, right?
Yes.
We're not splitting this into some sort of graph.
No, in this case, it's a side effect split, but then back into the main pipe. Yeah, if that makes sense. Yeah. And then get and report is some nice syntactical sugar that pipeable gives you, which basically takes any symbol that it gets and then knows to actually call whatever method that you have in your implementation within this class, send a message to those methods, if that makes sense, both get and report. I'll show you what those look like here in the next couple slides. So let's actually get right to that. So if I condense down what I was showing you in the call method, right, and we focus on the get, now this is a private method within here. And you'll remember I was messaging it through the get symbol. So all Pipeable knows to do is it's saying, oh, hey, the person in this step really wants to do a get request. There's a private method called get. I'm gonna grab the method of that, an instance of that method. Now I can compose it. I've got all my composability. So what's happening here then is I have that result monad coming in, and then using the dry monads gem syntax, I can do a function map. So only if it's a success, I'm going to call this block over here that does the HTTP request to the URL, gets it with a timeout of 1 second, and if that's all great, it'll just wrap that back up as a success. Otherwise, if it's a failure, that block that you see that I'm pointing at right here, it just doesn't get called at all, and it'll pass through to the next step. In the case that I do have a timeout error, though, what I'm doing is I'm actually rescuing it in this case, and then I'm just going to wrap that error message in a failure. So very clean.
So it pops out of the timeout, pops out of that fmap call.
Yeah.
You're still caching it inside this method.
Yes. So in the case of the timeout fires, right, I want to catch that, turn that into a failure in that case. Yeah. And then I'm just doing a get to get that URL, and we're just going to check the status of it. And then I'm wrapping that message, like I said. So the last method to point out here is to report. So basically, in this case, what I want to do is, again, I have that result monad coming in again. I'm going to do a function map, and only if it's a success am I going to call this code right here. And so all I'm doing is a simple, hey, is the status 200, sites up? Otherwise, let's just print out the status that we got. So let's actually see how this runs when we build this out. So if we include dry monads here, because I'm going to do some pattern matching, I'm going to take that, I'm going to take dry monads here so I get the success or failure types. I'm going to bring in the xkcd input as my URL. And then I'm going to call the pipe here. I just new up the pipe. I call it on the URL. And then I'm going to pattern match on success and failure by using the in syntax in Ruby, if that makes sense. People feeling comfortable there?
Know, so like, I mean, this very much makes sense to Haskellers, I think, like this kind of pattern matching thing. But I didn't realize that looks like it's a pretty built-in thing that the Ruby that you have is sort of alternative.
Yeah,
pieces, like
yeah. It's really nice. Prior, I forget. It's pretty recent. It was in the 3.0 series of Ruby. I forget what version off the top of my head. I haven't written down on my site, but previously with case, the way it worked is you would have case and then when statements for basically branching logic, right?
So like if else kind of. Yes.
But now we can also have case basically do pattern matching, and the only way to switch that is by using the in keyword there. So that allows us to switch, and it's really cool because in this case, when the success comes through, I know that I have I have the success wrapped up as one object, right? In this case, it's a string. So in the pattern matching, it checks for success, unwraps that message, and then I can basically print it out at that point. Same thing with the failure. I'm going to unwrap that failure. I'm going to grab that error message, and then I'm going to split that out onto the command line. And again, you could have anything in here. It could be an array. It could be a hash. It could be other objects. And you can unwrap those. Like if you want to get more sophisticated, you can unwrap those so that you can have multiple arguments in there. Basically, it's a nice way to package things and send things down, which I think probably feels really at home on the Haskell side and stuff too. Yeah. Okay, so let's look at the output of this. Let's actually run this whole thing so you can kind of see how this all gels together. So if we have that input of that fully formed URL and the site actually is up, you're going to get this. You're going to see the check. So there's the T step, right? It's checking to see if that URL, and it's spitting that out to standard out. Doesn't do anything else with it, but just says, hey, I'm checking this URL. And then if the success is 200, the site's up. In the case in which we send it without the HTTPS, so we're not doing a secure request, it's going to be a failure because we're going to do that check that does the regular expression to see if the H is on there, or sorry, the S is on the HTTP, and it's going to be a failure. And then in the case in which basically we're going to a URL that doesn't exist at all, it's going to hit that timeout. So there's that timeout. We caught that, we wrapped it up in a failure, and then we pattern matched and spit it out here into the console. So let's rewind that just really quickly here. If we go back and we look at all those steps, right, and we go through this one by one, right, there's the URL that's coming in. Now what pipe is doing is this is a string. And remember, each step has to have a monad coming into it. So what pipeable does is if it's not a monad already, it's just going to wrap it as a success by default. That way it plays nicely with all the other steps. That's what's happening on the first. This is basically that input that you saw in the very early slides that Ruby uses as functional composition at the low level, if that makes sense. Then we have T just spinning out to the console. The check is doing the pattern match. Get is making that request. As is doing the casting, converting the HTTP response into a status object, which we can then ask to see what its code is and then report that. So what's nice about this is now you have something that's really readable that you don't have with native Ruby composition that I was showing you in the earlier slides. Because in this case, I can read, the I reads from top to bottom all the steps in the pipe, which is great. If I was to blow this out horizontally and just come to limit the steps, right, it looks really good that way too. It reads from left to right. There's no this start from the right, left to right type thing, or read right to left. It's all just one flow. The I moves really well. And then architecturally, then to get to your point, like you were asking before, right, there's our raw input coming in. Those are our steps, but in between each step is that monad. That's what glues us all together. Then that gives us our pipe. And what's nice about this then is back to the railway pattern is if the first input comes through and it's just a failure, it's just going to skip all these steps in red and pop out as a failure in the end. It doesn't blow up, it just bypasses all of them. In the case in which the first two pass, but then you get a failure, it's just going to pop out as the last three. It's going to skip those. And in the best case scenario, right, where you have fault tolerance built in, where let's say that we are doing that HTTP request and it's a failure. And this happens a lot with third-party APIs, right? I do this all the time with integration work. Like I'm calling out to a third-party API. I know that they're terribly unreliable, but they're part of our core system, so we have to deal with that. And so when I was doing the timeout of 1 second in the code that I was showing you, basically I could get that timeout error and I could say, okay, let me do an exponential back off here. Let me actually wait 2 seconds, call again, because I know they're flaky. If I just keep hitting them, I'll finally get the result that I want. If that doesn't work, maybe I wait 5 seconds and then 10, and then at a certain limit, I cap and say, okay, I give up. This is a failure. Go ahead and wrap that as a failure and pass it down. So again, this is the value of using monads and fault tolerance. The railway pattern is that I can have that built into the system, and I can basically turn that failure into a success, and then the as and the report steps pass in the end. It just took longer than it did in the original example that we were running through. So in the end, we're using function composition, natively Ruby, with a little bit of monads from the drive monad gem, and then we're wrapping this all together in the pipeable gem, which I maintain. And that is basically function composition in a nutshell in Ruby. And if you need any of this, the slides and the community is here if you need the QR codes.
A question about what do you mean by monad? You can explain what monad means in this talk.
So in this talk, it's basically it's basically the composite type.
Something that has a failure.
A success or a failure. Yep. It's one or the
So
other.
basically, it's like in Haskell, either one.
Right.
Yeah, I don't know the equivalent in Haskell because, like you were saying,
in Elm, what would be the name of the type?
in Elm,
It's on the Rust.
I don't.
I actually forget what it is in Elm. I think it is result. I'd have to go look. I'm not sure. I think it is result. I might be wrong.
When I saw the okay an error, I was like, oh, did Rust like take this type from Elm? Like, is that like where they got their naming from? But
so Rust calls it a result, and they have okay and error as well.
Exactly.
So one of the fixed monads have is like the recovery from failure is not natively monadic. It's not a monadic thing to recover from a failure, right? And look at the recovery. So you're going beyond the monad. The concept of the monad is time to recover.
Oh, okay, so normally in what you're saying in a monad is there would be it has built-in recovery, is what you're saying?
No,
No.
monads don't.
Oh.
The monad concept of itself doesn't handle recovery.
Okay.
It sort of has
You
the,
don't go beyond.
yeah,
Okay.
specific.
Kind of basically what I'm doing here
Yeah.
with the pipe. Yeah.
A
Okay.
specific monad can provide you specific combinator to recover. But monads generically do not recover.
Okay.
Right? So if you think of this as a type of a parameter, right? So this parameter, this monad has only one parameter to specify. In this parameter, there's no place for error, just the success result. Right?
Are we allowed to erase whatever's on the board here, or is that not?
This is from last,
Yes.
meetup.
It's the same. It's the same.
Oh, is it?
We can
What you were talking about, though, you're saying at the top, right, you get your URL. and then I think you use a phrase, you wrap it in a moment.
I wrap it as a result, but I make it a success, if that makes sense.
So strange, but
And it looks like
Yeah,
it's the way of encapsulating.
Actually, no, this is not my
Various state options.
But yeah,
Well,
It's funny that-
in this case, it's not so much state. I'm just kind of wrapping it so that it'll play nicely with all the steps, because the steps assume that you're always giving it a result as an input, if that makes sense. Like here,
Yes, that's true. It's a fun.
yeah, like
Yeah.
if I go back here,
Because it allows you to, I mean, it's more rich than a try catch, right? Or it's not a binary result. It gives you the way to
well, so so the URL that is coming in, that's going to be, it could be a monad, by the way. I could be calling this from a different object that is sending over a monad.
So I'm trying to just highlight with right there URL. If it's a monad versus a string.
Yeah. So
Because to me that it allows it to, you're encapsulating all of the implied state options that are available to it.
not so much, you're almost there. It's not so much state. It's actually behavior. I want it to behave like a monad, which means that I can do the F map, the function map I was showing you on the, here, let me go back to the code here.
But
Just
you're
so
saying
they
if it's not a valid, right? If it's not a valid string.
yeah, well,
You could bail out right then, right? So that's to me, I'm using state, but maybe that's not the word that's productive.
yeah, here, let me go back to the report here. Actually, that is a potential, that would potentially cause an exception, I guess, because if somebody called the pinger class there, and I'm accepting a string, a URL to come in, but if somebody gave me an integer, I would still wrap it as a success, but when it gets,
That's too.
oh, okay, but it would blow up actually at that point.
It has to be a string.
Yes, because the rest of the code, the rest of the steps, they believe that they're getting a monad with a string in it and they're going to do something with it. But if they actually got like an integer, you can't do an HTTP request on an integer to 1, right? Like that's not going to work.
But to try to, I think, piggyback on the other question was, in that moment where it's not a string any longer, it's a monad object due to the dry monad jump, right?
Yeah, it's whatever came in, whether it's good input or bad input, it's going to be wrapped as a monad.
But in describing that difference, can we get at what definitions of a monad is in this case?
So monads, right? So is this dry monad gem defining many different monads?
Yeah, it actually
Or
has.
using a particular one.
Yeah, I'm using the result monad in this case, but they do have like a maybes. They have tries. They have list monads as well. I'm just showing you the result monad.
Yeah, so what I was trying to draw up here, it's sort of the Haskell view of the Haskell set, and it's the Ruby set, of like kind of like what a monad is.
Okay.
And so like, first you have like this pure, which just wraps some value, right, in like a no-op monad, right? So
Okay.
like in your case, it's a success in this result type.
Yeah.
Fmap is fmap, like that.
Okay.
Is
Is
very
it pure for obligative and return for that?
same thing.
Same thing.
Yeah. Return I'll just define as true. So I never use return anymore because it's just
Yeah,
over string.
sure.
Right? Just like, yeah. And then so bind is the last thing, which you kind of did some bindy things in there.
Yeah.
So bind is like where you have a value, you basically have a value like say success, you know, some success, whatever, and then you also pass in, you don't have types, so I'm trying to like, you have something that like takes whatever this wrapped value is, call it just like, we'll just say it's a string, I don't know, whatever.
Oh.
It takes a string and returns a result of, you know, some other type. It could also be a string, but whatever. But the point is that like you have a wrapped type and a function that takes the unwrapped value, right? Kind of like fmap. But instead of just returning, like, instead of just being a function string to string like fmap would do, it actually, like, the return value is also in the same monad.
Yes.
Right? So, like, it can, so that's the last function in a monad is this bind. So is there a binder?
There's a bind in monads too. I don't show it in my code, but yes. Same, so the same mapping.
Where's the semantics of dry?
Sorry, semantics of dry.
Yeah, why is it a dry mode? What is? Don't repeat yourself.
Okay. And so the entire ecosystem of the dry gems, like they do it for CLI, container, and so forth, right? It's like all, but
I think they're actually repeating themselves quite a bit. Maybe I should stop recording. Should I stop recording?
I don't know.
We can as well, right?
And so in the dry monad thing, like